Hello there and welcome back to the channel. If you didn't know that I'd been to Namibia recently, then perhaps you haven't seen the last two videos that I published, one about the planning and the rig that I took and the other one about the trip itself. It really was an amazing experience and I'd recommend you have a watch of those videos. Now I'm back in the UK, I'm in my study and I've got lots of data from the Namibia trip, and I'm going to process today the Carina Nebula narrowband data with RGB stars. So let's get started. So I'm here in PixInsight and we're going to start by having a look at the data that I actually collected in Namibia on the Carina Nebula. And you'll see first of all I've got 8 frames of 300 seconds on the hydrogen alpha, 12 frames of 300 seconds on the oxygen and 14 frames of 300 seconds on the sulfur. I also wanted to have RGB stars with this narrowband image, so I gathered 12 30-second frames on each of red, green and blue as well. Now because I had to photograph the Carina Nebula on 3 different nights because it was so low in the sky, descending from 20 degrees elevation down to 10, on the first night I did my RGB star data and my hydrogen data, but I only had that 1 hour between when it got dark enough and when the Carina Nebula dropped below 10 degrees, which is really where I drew the line. On the next night I did the oxygen, and the night after that I did the sulfur, or vice versa. So I got separate flats on each night just in case any major dust had moved around, either fallen off or landed on any of the optics, just to make sure that my flats were really good. So I've got separate flats for all of the different filters, red, green and blue, as you can see here. The red's down the bottom, yep, and we've got hydrogen, oxygen and sulfur, and I've gathered these as part of my sequence in Nina, which is quite convenient really, because it means that the flats get named with the same object name in the data from that night, so it doesn't get confused with data that I used at a different rotation angle on my rotator. So I've loaded in my lights, my flats and also the relevant darks. So I've got 300 second darks, 30-second darks and 3.1 second darks for the flat frames, and run weighted batch pre-processing. Now obviously you don't want to wait while that is happening, so I've already run that, and that's resulted in the red, green, blue and the SHO integrated data, which you see here. And we can take a quick look at the red. We'll just do an auto stretch on the red, then we can see the Carina Nebula. And here's the green, and here's the blue. And then let's take a look at the hydrogen alpha, which is always an exciting one. Really lots of great data there. In particular, I can see that I'm not saturated on the core. In fact, if it's unstretched, you can see that the core is not visible, so it's definitely not saturated, which is great news. And let's take a quick look at the oxygen data, which is here, and the sulfur data, which is here. So my data is looking very nice. I didn't do any pre-selection really when I used weighted batch before doing weighted batch pre-processing, because I knew that it was really good clear skies and the conditions were great, so I wanted to stack and integrate all of my frames, all of my subs. I didn't want to reject any of them. So that's my basic set of data that I got to work from. So the first step I want to do is to process the sulfur, hydrogen, oxygen into a starless narrowband image, and then I'll process the red, green and blue data separately to produce true colour stars, and then we'll screen the two back together at the end. So let's get started with that process. So I've organised the hydrogen, sulfur and oxygen so that we can see them nicely. They've all got an auto stretch on them, so they're still linear, and I've moved the red, green and blue data up to the top there out of the way. So the first thing I'm going to do is apply blur exterminator to each of these images separately, and then I'm going to apply star exterminator with the large overlap selected so that I get the best possible extermination of the stars. And then I'm going to apply noise exterminator, so it's all going to be done while these images are still linear, and then I'll do my stretching afterwards. So again, to speed things up, I'm not going to make you wait through while I do those steps. We'll just jump to what I've got after having run blur exterminator, star exterminator and noise exterminator. So I've run those now, and you can see here I've got some nice starless images in hydrogen, sulfur and oxygen, and there's a lot of dynamic range in these images, particularly in the hydrogen alpha and the oxygen. You can see that the core is very bright indeed. I mean, it's still on an auto stretch, but you can see there's a lot of nice detail around the edges, which is quite faint. But in the middle we've got this very bright core, particularly this region just here. And so I'm going to need to do some careful stretching on this so that I don't blow out the core, but still allow us to see these faint details around the edges. So I'm going to put these back I'll take off the screen transfer, basically put them back in their linear form and they're without screen stretch. And I'm going to start by doing actually an S-shaped curved stretch on the HA. So I'll bring up a curves transformation with a preview window, and we can apply an S-shaped curve. Now the idea of the S-shaped curve, if you don't already know, is to stretch the fainter things harder than the bright things. I don't want to get too aggressive with this S-shaped curve. I'm just going to apply it very gently at first. And you see it's not making a huge amount of difference. In fact, I'm comfortable to remove the preview there and actually apply this directly to my image a number of times. So I can decide when to stop. So that's twice, 3 times, 4 times. It's funny how sometimes it does it really quickly and then other times it takes ages. Okay, so we're now seeing the core is brightening up reasonably nicely, but the background is still pretty faint. So I've already started to collapse that dynamic range down so that it's less of a problem, but it's still, as you can see, quite an issue. So what I'm going to do next is actually use the generalized hyperbolic stretch tool, which is quite a bit more complex, but we'll bring that up with a preview window, and I'm going to use the generalized hyperbolic that it comes up with, and we'll start off by just zooming in on the histogram so that we can see where it lies, and we'll put a left click in the middle of that and send to symmetry point. So I've set the symmetry point and I can now start lifting up the brightness. Now I'm watching the core very closely here. I do not want the core saturating. You can see that it's just about starting to clip here. So I'm going to use the protect highlights feature. I'm going to pull the highlights down so there's less stretching going on to that core. You'll see it's actually bringing everything down. So I'm just going to now increase the stretch factor a bit more, and I'm now going to adjust the local intensity, and you can see now bringing up that faint detail in the surroundings of the nebula without too much brightness in the core. I like the look of that. It's maybe not in its final state. I think the background's maybe slightly too bright, but I like that. So I'm going to close the preview and apply that to my image. Okay, that's nice. So I'm going to do that basic process now to all three, and then I'm going to compare them with one another and look at how much intensity I've got in the nebulosity and what the general background brightness level is, because I want to try and get those reasonably well matched before I merge these three into a colour image. So I'll come back in a moment when I've applied that same stretching process to all three of these images. Okay, I've done that now, and you can see straight away that my background levels aren't all the same. So actually I find it easier to just use histogram transformation at this point. And what I'm going to do is just use the hydrogen alpha as the reference and try to get, in this case, the sulfur to have a similar background level. So I'm just lifting up the black level to try and get a similar looking level to the hydrogen alpha, and that looks about right. So I'll close my preview and I'll apply that to the sulfur. And now I'm going to do the same again to the oxygen. Bring up the preview and raise that black level. It's about right, isn't it? I'll close the preview and apply that to the oxygen. Okie dokie. So now we've got three images that are stretched and starless. We've got no clipping of any of the core in any of these images. It's quite bright. I'll just look here at the value, 0.7 in that bright area, about 0.7. Yep. So it's not clipping, which is good. And I'll check the hydrogen as well. 0.69. Yeah, quite similar actually, around about 0.7 in the core, and in the sulfur you can see it's quite a bit dimmer, even that very bright point there. Okay, 0.98. I've gone a little close there. Okay, so now what I'm going to do is combine these three to produce a color image, and I'm going to use the technique that Adam Block has recently posted on YouTube, which seems to work really well. And he starts out by just using the hydrogen and oxygen to form an HOO image. So we'll do that first. So I'm going to use Pixel Math. You can use Pixel Math or channel combination actually. In fact, let's use channel combination. That's just as good. Channel combination, and I'm going to choose the hydrogen as the red, and then the oxygen for the green and the blue. There we go, and go ahead and form our image. There we go. Now you can see it's actually quite dominated by the hydrogen. So I probably want to lift the green and the blue, so the oxygen in this case, up a bit more, or drop the hydrogen down. So I am going to cancel that and bring that up with Pixel Math, and we'll do this in Pixel Math so that I can apply some scaling. So I'll just put in the identifier of each of my images. So I need to split into RGB, so I've got the hydrogen in the red, the oxygen in the green, and the oxygen again in the blue. But now I'm going to apply something like times 0.7 to the hydrogen. We'll create a new image that's RGB and we'll run it. I always choose the wrong one there. Choose the square instead. Okay, how does that look? Alright, maybe I've gone slightly too far. Maybe I want a bit more red there, so maybe I'll go 0.8 and we'll run again. Okay, I'm getting a reasonably nice balance here between the red and the blue, which I'm happy with. So that's the first step in Adam Block's narrowband process, and the next is to bring in the sulfur by blending this image with a colorized version of the sulfur image. Okay, so the next step is to colorize the sulfur image. So I'm going to select it and then do Script, Utilities, NB Color Mapper. I'm going to choose the S2 Starless image, and I'm going to set a color somewhere around about the orange, and it's very yellow at the moment, so I'm going to increase the saturation maybe to 0.85 for example. That doesn't look too bad, and then I click update here and click the green tick to apply that, and that will create me a separate colorized version of the sulfur 2 image, which is this sort of goldy yellow color. And note that I think the background neutralization is actually on by default, so it is on. So we can close that now, and here we've got our sort of gold colorized version of the sulfur data. Okay, so now that we've colorized the sulfur, we now want to blend the SOO image with the S2 image. So we're going to use Script, Utilities, Image Blend, and we'll choose the base image as the HOO image. And just to make this actually a little bit easier, I'm just going to change the identifier from here from image 27 to HOO, and here this one to S2, and then bring up the image blend tool again, and now we'll set the base image as HOO and the blend image as S2. Okay, and you can see at the moment it's putting the S2 in too strongly, and we're really losing that HOO. So we need to adjust the amount of, or if you like, the opacity of the blended image, the sulfur image. So I'm dropping the opacity of that. So if I drop it right to the bottom, you'll see that all we can see is the HOO image, right? And I put it about halfway, and we're getting some sort of balance there. It's actually not looking too bad. Maybe a little bit less, a little bit more. This is very much down to personal judgment. Okay, so I'll drop that a little bit more actually. Okay, so once I'm happy with that, I can also adjust, if I want to, the black point, the mid-tones, and other parameters. Obviously the black point is going to kill your background if you put it too high. And let's try just adjusting those mid-tones a little. Okay, reasonably happy with that. We want to create a new image. The blend mode is screen, so we'll just hit the tick, and that will produce our blended image. Okay, so let's minimize these others. Let's get them all out of the way. Okay, so now here's what we've got. It's not the traditional way up for the Carina Nebula. I will do a 180-degree rotate fairly shortly, but that's not looking too bad. I could do some more adjustments. I actually tend to now export this or save it as a 16-bit TIFF, and then take it into Photoshop, where I use Camera Raw filter to adjust things like clarity and saturation of colours and the like. So I'm just going to do that and just improve this a little, and then bring it back into PixInsight to blend in the stars. So let's save this as my image blend.tiff, and I'll make that 16-bit so that Photoshop can recognize it. So let's now head into Photoshop. Okay, so I've got the image open in Photoshop. The first thing I'm going to do is create a stamp layer. Control-Alt-Shift-N followed by E, and release. I actually need to. There we go. There's my stamp layer, and now I'll do Filter, Camera Raw filter, and I'm going to start by going into Effects, and I'm going to up the clarity a little bit, to make the image a bit more punchy, and I'm going to use dehaze, which will both drop the background level a bit, improve the contrast, and increase saturation, but I don't want to go too far with this, so maybe about to there is quite nice. Now I'm going to go into colour, and I'm going to increase the saturation a little bit more to really bring out the colours. At the moment I feel like the blues are really quite weak and everything's sort of reddy orange, so I'm going to pull the colour temperature more towards the blue. And now we're getting a really nice balance of colours. I'm really starting to like that a lot. So I'm going to stop there, and I could just drop the highlight slightly. That core is looking quite bright, isn't it? I don't want to do it too much, because the core is bright, so I don't want to misrepresent it too much. So that's okay. So I'll hit OK on that. And now that I'm happy with that, you can see the before and the after. It's made quite a dramatic difference to how this looks. So I'm now going to do File, Save a Copy, and I'm going to save this as Image Blend Edit.tiff. Don't care about the layers, don't want the layers in there, just save it as a TIFF, and OK. And now I can go back into PixInsight. We'll close this image and we'll open the one I've just created, which was this one here. There we go. So now what I need to do is to add the stars back into this image. So I'm going to put that to one side, and we're going to process the stars so that we can then screen them back in on top of the narrowband starless image. Okay, so I've just had a little bit of a tidy up. I've now got my red, green and blue images after they've been integrated by weighted batch pre-processing. So the first thing I'm going to do is do a channel combination to produce a colour image. So I'm going to go straight to that. I could do a blur exterminator, or could even do that after I've combined them. So let's get this done. So red, green and blue. And apply it. I'm now going to close the red, green and blue images. So this is now our combined image. Let's just do a quick screen transfer function on that so we can see what's going on. You can see it's very red and the background is actually not right. So what we could do is a background normal neutralization, but actually you don't need to do that if you are going to correct your star colors using spectrophotometric color calibration, or SPCC for short. So that's what I like to do. So I'm going to pick, for the QE curve, I'm going to pick the Sony IMX571, which is the sensor in the ASI 2600mm. And then I've got Barda filters, so I'm going to choose Barda red, Barda green and Barda blue as my filters. And now I'm going to set a region of interest. So I'm just going to create a little preview. Maybe we'll pick a little area up here, for example, and we'll switch on region of interest. For the background neutralization, I'm going to drag that over the tick on region of interest, and now remove my preview like so. And now I can apply the SPCC to this image. Now it takes it, it needs an astrometric solution first. Okay. I often forget that step, so what I'll do first is go to Script, Image Analysis, Image Solver, and it's already got the date and time of the acquisition and my focal length in there correctly, so I can just hit OK, and that should do an image solve and produce an astrometric solution for this image. I'm going to jump ahead because it takes a little bit of time. Okay, so it's produced an astrometric solution, which is great, and now I can apply the spectrophotometric color calibration to the image. This one is fairly quick, so I'm not going to speed it up. I'll actually just wait this one out for it to do its magic. It's a nice little moment, this, when it just gets those colours right and the background just goes nice and space coloured, nice and neutral. And we should get two plots with lots of green dots clustered around a straight line at 45 degrees. That's what I'm expecting, but we should also see our corrected image. It's nearly there. There we go. Very nice. Okay, so those plots look great, and you can see we've got a nice neutralized image here. Remember, this is still linear, so it's, there's not much clipping going on in here, but now the colors are correct, and we can now look to apply a stretch. Incidentally, I want to get the nebula out of this because I just want RGB stars. So actually the next thing I'm going to do is run Star Exterminator on this. So bring up Star Exterminator. Now I want to generate a star image. I want to do this as well as I can, so I'll keep the large overlap, and I'm going to tick unscreen stars as well. Now this one does take quite a while to run, so I'll be back in a minute when this is finished. So let's just start it off, and I'll be back in a minute. Okay, so Star Exterminator's finished, and you can see we've now got an RGB star list, which is actually quite interesting. I could produce a nice image from that quite separately, but that's not what we're interested in this particular session. And then here's the stars. Now remember, these are still linear, so unstretched it looks like this, whereas the image on the right, the starless nebula image, is already stretched. So now I need to stretch the stars image. Now to do this, what I'm going to use is the generalized hyperbolic stretch tool, except I'm going to change the transformation type to arcsine H, which is better for stretching stars. So we can now start to apply a stretch to the stars. If I go, let's go too far, so you just see how far I could go. We go pretty crazy. There's an awful lot of stars in this part of the sky, as you can see. It's really part of the Milky Way here, so it's really very much a choice as to how far to go, how far to push these stars, but I tend to like something about like that, and we can now ditch the preview and apply that to our image. So we've now got stretched stars, and these are looking quite nice. Quite happy with those. A little cluster of stars down there as well, a little open cluster. Lovely. Okay, so I'm happy with that. I'm going to rename that stars, and I'm going to rename this one starless. And now I'm going to bring up an equation which I keep in my little reference on my other screen for screening stars back in. And so to do that, I'm going to use pixel math. Okay. And it's going to be using a single RGB expression, and this is the expression. So it's a rather peculiar expression. We invert the star list, multiply it by the inverse of the stars, and then invert the answer. So let's apply that and see what happens. And as usual, I pressed the wrong button. There we go. Okay, and now we have the stars screened back in. So that's done a really nice job of adding the stars back in. And for some reason, although there's no right and wrong way up for an image like this, in general the Carina Nebula is normally, images are normally the other way up to this. So I'm going to use fast rotation, and apply a 180-degree rotation to that. There we go. That's the more familiar orientation of the Carina Nebula. And let's just make this a bit bigger so you can see what's going on. Okay, now I've still got some little residual artifacts in the corners where I haven't cropped it, and we've got some small stacking artifacts in the corners. So I will do a dynamic crop, but other than that, we are just about done. So I'm gonna just put in a dynamic crop. Okay, so I'm going right down to the corners and make sure that I'm really only removing the part of the image that's got the stacking artifacts in it. Doesn't look like I've got any stacking artifacts on the right there. Let's have a look down the left hand. I've got some artifacts at the top. And let's have a look down the left hand side. Oh, that's almost spot on. In fact, I'll accept that as it is. Okay. So there is my end product. I have to be honest with you. When I process this, every time I process this, I do it slightly differently, and I get a different colour arrangement between SH and O. And a lot of the time when I do it, I think, oh, I like that more, or I like that less. So it's really a good idea to keep doing this over and over and changing the balance of the HOO with the S2, the colour you choose for the S2, and what you do in Photoshop if you do it the way that I do it. But I'm really pleased with that result. I think it's a really nice looking image, but it's always personal taste, isn't it? Hope you enjoyed that. I'm going to do a separate video like this for a number of other image data sets that I took out in Namibia, but that concludes the first one, the Carina Nebula in narrowband with RGB stars. See you next time.